Okay, when we take a look here at line 1, the variable a, that identifier, is being declared an integer, and it's assigned the value of negative 24. So negative 24 is going to output when we run this system out print line a. So negative 24 prints to the console. Negative 24 is an integer. Integers are positive or negative whole numbers. There's no decimal component, so negative 24 is our output. Okay, then we go down to line 2, and we're asked to take a, which is currently negative 24, add 2.5. When you add an integer and a double, the result becomes a double, right? So that would become a problem because it's asking us to assign now the value of that double to a, and a is defined as an integer. An integer cannot store a double, so this is going to cause an error. And the instructions said if the line causes an error, you should write error in capital letters in the box, so ERROR, and comment out that line of code. So we put 2 slashes in the front to comment out the line, and then we continue on. So when this program would run, line 1 would output negative 24. Line 2, because it's commented out, doesn't impact anything's value. So now we come down to line 3, and let me get my highlighter back. So now in line 3, we're taking the identifier b, we're making it a variable of type byte, and its value is going to be 53. Bytes can hold those 2 digits, so we're going to output that byte on line 3 as 53. Okay, then we come down to the next line, which is a character data type. CHAR stands for character. We're going to assign C to that primitive data type of character, and its value is an ASCII code. So 97, when I want to output that variable C, since I'm outputting a character, I look up here on my ASCII code table, and I see that 97 is the lowercase letter a. And so the output for that line of code is going to be the lowercase letter a. Okay, now we look at line 5, and in line 5, now we have a double, right, that is called D, and that double, remember doubles and floats are decimal numbers. Doubles are bigger than floats. So we have a double named D, and its value is assigned 8, which is an integer, plus a. A, we look up, is an integer. So we're taking negative 24 plus 8, and then we're storing that answer as a double, okay, which doubles are decimals. Okay, and so that means, let me get my pen back, that means that our answer, negative 24 plus 8, is going to result in a negative 16, but we have to type 0.0 in with that answer of negative 16 because it's a double. Okay, so now we're coming back to the letter A. A, we know from line 1, is an integer. So this, oops, I wanted that to be yellow. So this line 6, right, is taking something that we know to be an integer. It's going to reassign its value. Its value currently is negative 24. So I'm going to take negative 24 plus, and then whenever you see a data type in parentheses before a variable, that's called casting. So it's going to cast whatever this variable's data type is into a different type. So taking negative 24 for the A plus, and then casting negative 16.0 as an integer. So it's taking that decimal and it's discarding it, so that now my the calculation I have to do is negative 24 plus negative 16. and that answer is an integer, so I can store that as a, and that value then, let me get my pen, is negative 40. And that negative 40 does not need, or it definitely doesn't get, a decimal after it because a is an integer, right? We don't have any decimals in our integer answers. Okay, so now we're at line 7. Line 7 is taking the variable identifier e and assigning it to type float. Float is a smaller data type than a double, but it's still a decimal number. And you have to use this lowercase f after you assign a value to a float, just to indicate that it's a float. And this float is the value 1.5. So when we output e to the console, it's going to output that value 1.5. It does not output the letter f at the end, right? That f was just there as part of the notation that's required in Java when you assign the value, a value to a float. Okay, so that brings us now to line 8. And in line 8, we've got D again. So let's get that pink highlighter. So here's my D, which is a double. And that double, its value is equal to the value of e, and e was a float, but that's being cast as an integer, right? Now, this is different from regular math. Casting is not the same as rounding, right? In like regular math, if you had 1.5 and you wanted to round it because it's a decimal 0.5 and over rounds up, it would be a 2. Casting is not that. When you cast a double or a float into an integer, it truncates or chops or amputates that decimal right off the end. So when you cast 1.5 into an integer, your result is going to be just 1, right? Now, this integer 1 is being stored in D, and D is a double. So it has to have a 0.0 attached to the end of it because doubles are decimal numbers. So that's a little convoluted how that happens, right? We're tempted to say that we're changing this float 1.5 into D, which is a double, and that might preserve the 0.5, the decimal place, but it doesn't because of this casting as an integer, right? Before it could be stored as a double, it was cast as an integer, which truncated the value 1.5 into the integer 1. And then it was the integer 1 that got assigned to a double, and so that decimal place, that 0.0, was put back on. Okay. Okay, so that brings us back now to line 9. I think I'm going to use orange for this one. So now we have an integer f, and this integer f is being assigned the value of capital A, and those single quotes on either side of that capital A indicate that we're going to use the ASCII value of that character. So let's go ahead over to our ASCII table again, and capital A has an ASCII value of 65. So this value right here is 65, and then we're going to add 6 to that value of 65 to get 71. Okay, and then that 71 will be assigned to the variable identifier f as an integer, and that doesn't cause any errors. That looks like it's okay. So we're going to output f to the console, and that will come as a 71. Okay, now we're back at line 10, and I believe we used blue. There we go. Use blue as the highlighter for character, and lowercase c has already been defined as a character with an ASCII value of 97, right? So now we're reassigning the value of c to the, remember the small quote or single quotes here with a capital letter tells us to get the ASCII value of that character. So let's grab our ASCII table, bring that back out one more time. So 67 is capital C. So we're going to take our lowercase c variable, we're going to assign it the value 67 minus 1, okay, which is 66. And so that, when we look at the table, 66 is capital letter B. So when we store C, it stores lowercase c with a 66, but we're outputting a character, right? System out print line little c is a character. And so that character is going to output its ASCII equivalent, which is capital letter B. Okay, that brings us down to line 11. We've got a double now, which is G, and I don't think we used G before, so let's grab a new color. What color should we use? Let's do this, I guess this pale purple. Okay, so we've got a double here that is the lowercase letter g, and that double is going to have the ASCII value of lowercase a, which was 97. We're going to add to that 6. Okay, so 97 plus 6, 103. And then we're going to make that into a double when we assign it to G, and so we have to put a decimal place onto the end of it. So that will output to the console 103.0. Okay, so that's lines 1 through 11 on the practice worksheet. I'm going to leave the rest up to you to work through and see if you can polish up whatever errors that you needed to debug from your first attempt, and then give that another try. Okay, thanks.